Okay, so today we're going to look at ratio. I'm mainly going to use this as a chance to go over some of the concepts that you've learned in the last couple of years, just to refresh you a bit. And then we're going to focus a little bit more on part-to-whole relationships and how to get information from some of these word problems and figure out how to solve them when your ratio doesn't necessarily have a part-to-whole relationship. You have to create one. And also a little bit to do with going from ratios to percent. So a few concepts here, but we can do this. So let's get the title on here, ratio. So ratio, as you know, is a general comparison of values. Okay, so it compares values. And it's the quantity or how much of one thing as it relates or is compared to another. As it is compared to another. So I usually say that they don't necessarily have to be the same thing. So you're not comparing the exact same, so say for instance blue stars to red stars because they're both stars, but they typically have some sort of a relationship. You know from grade 8 science and grade 7 science that you've done stuff with mixtures and fluids, and so you want to look at how much something's concentrated, for example. It's really good to sort of tease that out into a ratio. So the way that ratios can be expressed is if we have a ratio such as 4 to 2, you can write it like this with the little colon in between. You can also write it with the actual word 2, 4 to 2. You can also express it as a fraction. Ratios and fractions are the same thing. They all have proportional relationships. So when you're doing equivalent fractions, when you're adding and subtracting, for example, you're doing the same skills as we use with ratios because you're proportionately increasing or decreasing that relationship. So in this case, it looks like a ratio. When you learned it as a fraction, it looked like that, but this is also a ratio. We can also look at stating them in lowest terms. So 4 and 2, so if we go 4 to 2, you can look at that, and the same thing as with equivalent fractions or when you're reducing to lowest terms, you're going to look at both of these terms. So this is called a term, and that's called a term. So this is called a two-term ratio. Okay, because there are two numbers that we're comparing. So we want to look at those two terms and decide what can they both be divided by. If it was 4 to 3, you can't reduce it any further because you don't necessarily want to get into decimals, though it is possible. But for the sake of grade 8, we're not going to go into infinitesimal decimals. So you might be able to bring something down to a 0.5 on one side of your ratio. So one of your terms could be 0.5. But as soon as we start dividing and getting into decimal numbers, you can go on infinitely. So you want to be careful with that. So it mainly has to do with your communication. What am I trying to get across? And then you decide if you're going to go into decimals or not. With 4 to 2, we know that both 4 and 2 can be divided by 2. So what we're going to do is actually divide both sides. And you know that with reducing fractions to lowest terms, we'll typically say whatever you do to the bottom, do to the top. Now that we're dealing with ratios, whatever you do to one side, you do to the other. So we're going to divide both sides by 2. So 4 divided by 2 is 2. 2 divided by 2 is 1. And I'm going to look at this guy and say, okay, you know what, I'm good. I'm in lowest terms. Again, we could further divide by 2, and now we're going to get into decimals on one side. But again, for the sake of grade 8 stuff, let's just keep it mainly into whole numbers. So when you're wanting to look at missing values in a ratio, so we go back and we say, okay, well, we've got a value of something to 5 equals, say, 7 to 15. So what you want to do is you always want to be aware of the order of your ratios. So you're comparing this ratio, the one on the left, to this ratio. And remember at the top here, right, I was talking about what terms they are. So in the two ratios that we're comparing, this here is the first term of the ratio on the left side, and this is the ratio on the right side. And I've already realized that I made a mistake. So give me a second. I'm gonna keep these numbers as whole numbers. So we're gonna take this off. We're gonna get rid of that 7. Haha. Go back to red. And we're gonna say 30 here. So those two, the two blue stars, are the first terms of each ratio. And then say we put a little yellow circle, that's the second term of that ratio, and that's the second term of the ratio. Okay, so what you want to do is, because we have this missing ratio here, or missing term, sorry, not missing ratio, we want to see how we can proportionately increase or decrease that ratio. So what we're looking at is comparing the 5 and the 15. Okay, and just like when we were reducing to lowest terms above, you want to say, okay, if I'm going from 5 to 15 and I know it's a proportion, I can only multiply or divide. So to increase my ratio, I multiply. To decrease my ratio, I divide. There's no adding and subtracting. Same with equivalent fractions. You know this. So these are the same skills as finding the missing term in a fraction. So if I gave you something over 5 equals 30 over 15 and asked you to fill it in that way. Okay, so it's the exact same thing. So we want to look at, to get from 5 to 15, I have to multiply by 3, okay, if I'm going in that direction. Inversely, if I'm going in the opposite direction, if I want to go from 15 down to 5, I have to divide by 3. So whatever makes the most sense to you, you're going to use. So if you want to go back to this blank and think to yourself, what number times 3 gets to 30? Or you can say 30, if you want to go the other way, 30 divided by 3 equals what? Okay, so you have a couple options here. So if I'm just going to erase this down. It's a little bit, it's taking up room. If I want to do something times 3 equals 30, well, I know that 10 times 3 equals 30. If I want to say something 30 divided by 3 also gives me 10. So we're just going to keep the 10 in there. Okay? So if I want to take a fraction or a ratio, in this case a ratio, right? And I've got it in its lowest term form, right? Because again, I don't want to reduce that one down any further. So what I'm going to do is I want to scale it up by a factor of 4. Because remember what I said, you can multiply to scale a ratio up, or you can divide to scale it down. And scaling up and scaling down is basically the same as finding an equivalent ratio. It's just different language. It's a little bit more sophisticated because we can use ratios. You tend to use ratios more when you're dealing with scale drawings. And if you're increasing or decreasing proportions in a solution, so things like that. So you might see scale up, scale down, you might find it as equivalent ratio, so either way. So we want to take this ratio, this 2 to 1, and we are going to scale up by a factor of 4. So all that basically means is we're going to proportionately increase this ratio, 2 to 1, by a factor of 4. So if we're scaling it up, remember that we've got to go back to that and say, oh, I'm just going to multiply in order to scale it up because I want to make it bigger. So what we're going to do is we are going to proportionately multiply by 4, but because it's a proportion, whatever you do to the left, you do to the right. So 2 times 4 is 8, 4 times 1 is 4. And now that's a scaled up version of 2 to 1, okay? So your trick is always multiply or divide both sides, or all terms. Okay, so remember, this is term number 1, this is term number 2, but there is such a thing as a 3-term ratio. You could have a 4-term, 5-term ratio. So something to something to something to something, right? So whatever you're going to end up proportionately increasing or decreasing, you have to be able to multiply or divide all of those terms by the same number in order for your ratio to have a correct scale or a correct proportion. So there are 2 types of ratios. You have part to part. Okay, so a part-to-part ratio means that you're comparing items within a total. So we can look at, for example, we're going to do the ratio of brown to blue to green eye color. Okay, and I'm going to give you that number because we're going to start messing around with that number. So I'm going to tell you that the ratio of brown to blue to green eye color for the grade 8s at our school, and I'm just making stuff up, is 10 to 6 to 4. Okay, so now this is called a 3-term ratio because there are 3 terms, right? 1, 2, 3. 3-term ratio. It's a part to part because we haven't combined all of these students. We've said if I have a group of students in front of me, the ratio is 10 to 6 to 4, which means that 10 students in front of me have brown eyes, 6 students have blue eyes, 4 students have green eyes. The really, really important thing about ratio is the words have to match the numbers. So it has to be in the same order. So if I give you something to write as a ratio, say for instance this, I say what's the ratio of brown to blue to green, and I give you a bunch of numbers, and you give me back 6 to 4 to 10, it's actually incorrect because it's not written in the order that the words were written in. So you have to be very, very careful with that. So the first thing that I want to do is look at, okay, I'm going to reduce this to lowest terms. When I look at 4, 6, and 10, the largest factor that they all have is 2, okay? So I'm going to go through and I'm going to divide all of those down by 2. Okay, I can't divide 10 by 5, I can't divide 6 by 3, and then divide 4 by 2. So they all have to be divisible by the same number. And again, let's try to stay away from decimals, okay? Again, you can have them, but for the sake of grade 8 stuff that we're doing, for the most part, we're going to be dealing with whole numbers, and that's it. So 10 is divisible by 2. We do 10 divided by 2, we get 5. 6 divided by 2, we get 3. 4 divided by 2, we get 2. Okay? So if we know, here's where we start using this part to part. If I then say to you that there are 120 students in grade 8, just a little estimate. I think I'm pretty close, but anyway. If we use that estimation, and we have to figure out, based on this ratio that we have, what does that mean for the number of students in grade 8 that have each of those eye colors? Okay, so it's really tricky to just go, oh, 5, 3, 2, how are we going to work up from there? So what you want to do is you want to create the whole. So right now we have a lowest term ratio, so obviously our lowest term ratio has pretty much nothing to do with this 120, okay? Because when I look at this lowest term ratio, I'm never going to get to 120 by just looking at 5 kids and then 3 kids and then another 2 kids. But if I add all of these together, I have 5 plus 3 is 8 plus 2 is 10. So this is my, I'm going to call this brown just to keep track. This one's going to be my blue, and then this is going to be my green, okay? But now what I want to say is what's my total? Okay, so I could turn it into a part to part to whole, or a part to whole, but I can also just say over here that my total is 10. Okay, and I'm going to use that information. So even though it wasn't explicitly given to you, I'm going to erase that, it's a disaster. Even though it wasn't explicitly given to you, you can find that total in order to use it for whatever it is that you need. Okay, so that's my total. So what's that saying is in every 10 kids, 5 of them would have brown eyes, 3 of them would have blue, and 2 would have green. So we want to figure out, what does that mean for this 120? Okay, so I now want to look at coming up with an equivalent ratio that gives me 120 at the end. So I have this, this, and this now to fill in. So I've got to find my brown, I've got to find my blue, and I've got to find my green. Okay, so I know that my total is 10 in my lowest term ratio, but now I want to find out how I got from my lowest term ratio to my total number of students. And you can see that we multiplied by 12. I hope you can see that. To get from 10 to 120, again, if I want to proportionately increase it, I times by 12. If you can't look at 10 to 120 and know that you're multiplying by 12, go backwards. Okay, so this means I'm going to multiply, but to get from 120 down to 10, I know I have to divide by 12. Okay, and then at least now you know that you've got this factor of 10 that you're working with. And then what we're going to do is apply that to these 3 ratios. Okay, or this ratio, sorry, these 3 terms inside of that ratio. So I'm going to do 2 times 12, and I'm going to get 24. Okay, I'm going to do 3, this is going to become a total mess, times 12, and I'm going to get 36. And then I'm going to do 5 times 12, and I'm going to get 60. Okay, so now I know that because I have 120 students in grade 8, I know that 60 of them have brown eyes, 36 of them have blue eyes, 24 of them have green eyes. How do I know? I'm going to go back. I'm going to check over here. I'm running out of room, so I'm going to erase a couple things. I'll just erase this little, whoops. I'll just erase that little blob. Okay, so this is my check over here. Okay, 60 plus 36 plus 24. So 60 plus 30 is 90, plus another 20 is 110, 110. And I know I've got a 6 and a 4, so 6 plus 4 is 10, so I got 120, okay? Instead of having to do that on the calculator, you can sort of chunk it out, do it in your head, and we're moving on. Okay. So now I want to kind of relate everything into percentages. So I want to get a percentage from whatever ratio I'm working on, okay? I want to go back to that lowest terms. You don't have to, but I'm going to go back to that. So my lowest terms was 5 to 3 to, 2, okay? And if I add them up, remember, I ended up with 10 total. Okay, so if I want to be able to express each eye color, so each eye color as a percent of the whole. Okay, I can go back to this total of 10 and I can say, well, brown gave me 5 students out of 10, and now that's a part to whole, and I know that 5 out of 10 gives me 50%. Okay, blue eyes is 3 out of 10, and I know that's 30%. And green is 2 out of 10, which gives me 20%. Okay, and again, if you want to have a quick look, 50 plus 30 is 80 plus 20 is 100. So I should still have, if I'm dealing with a part-to-part that relates back to a total, I should be able to combine them all to get 100%. If you just need a little recap, so I'm going to throw a little sidebar over here. Remember, if we have 5 out of 10, we know that percentages are always out of 100. So I can multiply by 10 on the bottom. And remember your powers of 10. I don't even multiply by 10, I just add a 0. Whatever you do to the bottom, you do to the top. So I'm either going to multiply by 10, or I'm just going to add that 0. If I add 1 to the bottom, I got to add 1 to the top. Or another thing you could do is do 5 divided by 10, and you get 0.5, but then you have to remember that you've got to multiply by that by 100, and you get 50. Okay, so I think a lot of you are okay with doing this, this kind of concept. We've gone from percentage to fractions and to decimals all through the probability unit. A lot of the reason was to get you ready for this, and also it's good to kind of weave all these concepts in together. So we're going to look at something where it's not so easy, so we're not dealing with something out of 10. So I'm going to look at, in my breakfast bowl, I have a bowl, of fruit, and my ratio of big fat strawberries to blueberries. It's going to give me a ratio of 3 to 14. Now, or sorry, 3 to 11. So what that means is I could have in my bowl of fruit 3 strawberries, and I could have counted out 11 blueberries. It could also mean that I have 6 strawberries in there and 22 blueberries, and I've decided to give you the lowest terms. You don't know that, right? The only thing that you know is that the 3 relates to strawberries and the 11 relates to blueberries. So remember what I said, if I give you a bunch of quantities in a list and I ask you for blueberries to strawberries, you can't write 3 to 11. You have to write 11 to 3, so you've got to flip it around. So you have to be careful that your numbers go in the same order as the words. So now we're at blueberries and strawberries in my bowl of fruit, and I want to know the percentage of each. So again, because we're dealing with a percentage, it doesn't matter if this is in lowest terms or not. This could be 9 to 33. It doesn't matter because your percent is going to come out the same way anyways. So what I do need to know in order to deal with percent is what is my total, because a percent is always a relationship to the whole. So I know that I've got fruit in a bowl, and I know that it's broken into types of fruit, but essentially I know that I have 14 pieces of fruit. And again, it could be 20, 28 pieces of fruit, who knows? But I've got 14 pieces of fruit in my lowest term ratio. So I'm going to relate my percentage back to those pieces of information. So I'm going to take my little white pen. This is what you need. So again, this is what you were given, this 3 to 11. You've got to remember that anytime you're coming up with a part to whole, percentage as a whole, you've got to add those terms together in order to figure out what the whole is. Okay, so I'm going to do strawberries. I'm just going to call it straw, sorry. And now I'm going to say that my part is 3. And I'm going to relate it as a part to whole ratio of 3 to 14, or 3 out of 14. And I want to turn that into a percent. So the way you do it this way, because I can't come up with a multiple of 10 or 100 or like anything that works into 100 as my denominator. So what I'm actually going to do, remember that this bar on your fractions is actually a division bar. Try to remember that, right? I keep telling you guys that. A number over another number, right? That's where you get that symbol from. So we're going to do 3 divided by 14. So if you need things to remember, top divided by bottom. And some of you are already know how to do this, even when it's just coming down to figuring out what your percentage is on a test or something like that. So 3 divided by 14 equals 0.2142 blah 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 blah. So I'm okay with you saying that it's approximately 21%. Okay, because remember, to get to a percentage you have to times by 100. Move your decimal twice. Okay, multiply by 100. For the blueberries, we'll say bloob. I have 11 out of 14 as my lowest terms. And so I'm going to come in and I'm going to do 11 divided by 14. And I get 0.7857. Okay. I want to look at 3 numbers after the decimal, because then it can help me round. And again, I'm making a mess with my pen, so I'm going to try and erase this and clean it up a little bit, sorry. So that's a 7, 8, 5. I want to go 3 over, because remember I said that you've got to move your decimal 2 to the right in order to multiply by 100. So if it's 78.5, I can say that it's approximately 79%. Okay, you want to be more precise, especially as we get into higher grades. Your teachers are really going to be looking for that. So you can't just decide that 785 is roughly 78%. You want to round it. So those, like all these little bits and pieces that we teach you as you go, how to round, can't even think of anything, how to estimate numbers, creative rounding, you know, if you're rounding because of money, you've got to round to the nearest hundredth. If you're, you know, trying to find how many cans of paint at a store, you can't buy 7.285 cans of paint. So even though the number's 285 and it's low, like it's lower than 0.5, you still have to round up the can, because you can't purchase a partial can of paint. So these are all the skills that you kind of develop and you get more comfortable with. Anyway, I hope that's given you an overview of ratio, as it relates to a little bit of review, and then also how you can use that part to part in order to figure out a whole, and then to be able to kind of scale it up or scale it down to figure out your missing ratios, as well as getting percents. So there's a lot of concepts in here, but your homework's going to be asking you questions that relate to those concepts. Okay, so let me know if you have any questions.